For our last class, we have introduced talk about the smart devices, and then we give some definition, and then we're going to use the Raspberry Pi for our project and use a lot. So just quickly go through some backgrounds. We'll know the Raspberry Pi. So it's a series of small single board computer. So they developed in the UK, okay, by the Raspberry Pi Foundation. So they want to promote the teaching of basic computer science in the school as a beginning. And then later, because the original model becomes far more popular than the anticipated selling outside, its target market for the use such as robotics. So here's the reason for robotics and more control. Small Pi with good performance. Okay, so later after the 5 million Raspberry Pis being sold before the February 2015, so it makes it the best-selling British computer like this. And then by November 2016, then already sold 11 million. So that's why it rapidly goes up. You see, it goes up crazily. And you don't have to really memorize all this information, just knowing, okay, first start with the first generation Pi 1 with Model B released in February 2020, and then simple, inexpensive Model A, and then 2014. Then the foundation released the book with improved design with Pi 1B plus. And it's approximates the critical size and present the standard, the form factor, and then they keep on improving A plus AV model, and then release the a year later. So it's more like a computer model. Okay, it released in the April 2014. So the application, and then Raspberry Pi 0 with a smaller size. They reduce the I/O and also some GPIO capabilities. So they released in November 2015. Okay, so it's way cheaper. Okay. And later for the Pi 2, they add more RAMs, and then the later more popular is the Pi 3 Model B from the February 2016. So they bundle the onboard Wi-Fi, Bluetooth, USB boot capabilities. So it's getting more powerful. So when from the 2017, so Pi 3 Model B will be the newest mainline for Raspberry Pi, and the price you see pretty cheap. Okay. So far we see all the models that feature is the Broadcom system, so on the chip, and then including the ARM capability. So I know some students use it to learn the machine learning assembly language, but this one also supported more let's say the CPUs and the on-chip graphic GPU and also video call. So it's really a small and minimized computer. So the CPU speed range from the 700 megahertz to 1.2 gigahertz for the Pi 3. So it's getting good performance. And then its software is really good enough for smart things, like for IoT. So 24/7 is possible, it's work. But sometimes we do for release the memory, then sometimes we set the regular task, the control, then we can reboot regularly, weekly or monthly, to make sure the performance stays stable. Okay. Also, they allow the secure digital SD card to store the OS system and then program the memory, either the SDH or micro SDH size. So it's pretty good. And most about maybe between 1 or 4 USB port, it comes with the HDMI's, and then they composite the videos output, and then 3.5 and then phone jack. Okay, so all these, and then they also have a low level outputs that provide number GPIO pins, and this we use a lot when we need to connect different types of sensor and then some other devices. And then B model have we call the AC, the Ethernet port. So we can connect not only Wi-Fi, but also we can connect to the Ethernet port. But now that we also have a Wi-Fi and Bluetooth, so it's really good. And then later they provide the Raspbian. So it's the Debian-based Linux distribute share. So you can download it. And also, of course, you can try to add others OS. Really depends on use. And mainly it comes with the Python and then the Scratch. So they are mainly programming language. So maybe some of them Scratch for some beginner. So it's pretty easy. And Python is a language we use a lot to write the program. So it's mainly, so the different from is the code source. So there's an unofficial open source also available, including we have the I/O, we have the RAM, and the CPU, GPU come together with the USB, and then you can put the Ethernet port, and then depending on size. The one I'm having is including the HDMI 3.5 and 4 USB port with the Ethernet port. So yeah, you see. And for the all more details right here, so if you are interested, we're gonna look at this part. So if no, then I will jump a little bit about the processor. So it's from the Broadcom BCM 2835. So it's the first generation the Raspberry Pi they're using, and then we keep going, including from the OS we learn we have level 1 L1 cache, 16 gigabytes L2 cache 128, and then level 2 cache used for primarily by the GPU. So it's how it works. And the Pi 2 using a Broadcom BCM 2836 with the 900 megahertz, and then with the 32-bit, and then keep going up, and then Pi 3. So this we need to know is that when I say 1.2 gigahertz with the 60-bit core R. So it's like we're using nowadays. It gives the for the Pi 3, so we can say 10 times performance better than the Pi 1. So really high depends upon the task, also depends how we use. So kind of like Pi 3 will be 80% faster than the Pi 2. And the comparison right here, like Pi 3 can have a 1 gigabyte RAM, and then for the lower version 0 with the 12 megabyte. Okay, for network, so you see maybe older version they don't have Ethernet, but we only focus on nowadays. We do have a Wi-Fi, support Wi-Fi. So if you install the one with the GUI, you can just click on to connect to the Wi-Fi, or if you are using the just the server, then that one you can use the command line to connect the ETH to connect to the Wi-Fi, and then with the password. So either way is okay, or you can directly plug in using the Ethernet port. Okay, so it support the maximum is 100 megabyte, so you can use. So for the hardware other details, I'm not go through all about this, just to let you to know, and all the support, all the image. So for this one, I will show you all what you need to install. We have so many different types, and everything we are working will stay on the Raspberry. Okay, so we are going to install, and just like quickly jump through all the details, say other content, and usually the communities nowadays and online so many a lot. Okay, also there's a called a map time, so it's also the fancy for the users for the Raspberry Pi computer. So also you can look at it, and I'm not really go through all this one, like even the Pi C also is shorter. And model A, so you can see the graph, and model B. So mainly I will just jump to the latest one with the I think most of you are getting the Model 3 or the latest one. We have the USB port, that's what I have, and the RJ45 is the Ethernet, and then we have the 3.5 for the medium power, and then you can connect to the camera. So in case your project you need to use the camera, then you can insert to this part, and you can have a HDMI output, and also they have for the power micro USB, and also you can insert the your micro SD on the side, and then for the system, and then they come with the Wi-Fi. So right here, and also here's the pins you're going to use will be the you will see the CPU GPU chips right here, and then the Ethernet controller right here. And later for the pins will be all the GPIO. So right here, so we have the like 5 floor, 3 row, and then for the inputs later we will write a Python script to check all the inputs. Then we check all the details later. Okay, and they always like come with different type of different accessories and other hardwares. So feel free to get it and install it. Okay, just when you think you need for your project, you feel free to add those. And so far, here's a quickly go through about what's the Raspberry Pi. And for the content, for the IoT stuff, and I will cover later for the first part of the lab. And I would like to let you to set up the Raspberry Pi. So I give you all the steps, because we mainly using Raspberry Pi for the IoT or smart things security. Then first we need to know, okay, how can we integrate the Raspberry Pi with different types of security protocol. But for the beginning, then we need to set the Raspberry Pi first, right? So you need to get the, I think most of you have the Raspberry Pi, and make sure you have a micro SD. And then in the Raspberry Pi, if you are going to access through SSH, then maybe you do not need the monitor or keyboard. Then you can use your own laptop to connect to it. Make sure it's just online. Okay. And you need to set the Raspberry Pi OS VPN, and also connect through the secure shell, the SSH for remote access, or sometimes we can add the OpenSSL. That's what you need to do. I give you here set the lab, and for the access, you also need to create the SSL communicate through the SSL and TLS, and then that's what you need to do. So for the first step, you need to download is the image Pi. So after install it, then you can get it, and after you choose it, then you can, okay, even when maybe you are using the Pi 5, then your Pi 5, and then you can choose the OS Raspberry Pi with 62-bit, though that's we are going to use. So it's based on the Debian. Then you can choose the storage if you after you install it. So after you complete all the settings, then you can write the OS to your micro SD. After you finish the installation, then you can just put it in, set up everything. Or if you able to, we call the headless, that means you can just power it on and connect with the Ethernet, then you're good enough. Okay, then after you change, it pops out. By default, I remember it's like the Raspberry, and then the name is called Pi, and then password Raspberry, and then you need to change default username and password. So you go through all this step, and suppose it will be pretty straightforward. So I didn't go through all the contents, and make sure you enable, go to the Raspberry config and enable the stable interface option and enable it. So all this after you complete, then you're able to do it. And our main focus, first you need to do is update and upgrade, and try to allow the OpenSSL for the encryption. And for addition, you need to install the fail to ban. So also include the UFW for this one. And after you finish all the setting, these are mainly the steps you need to do. So you can create a self-signed certificate using the OpenSSL. So here's the complete instruction. So you can copy OpenSSL chain key request and then out for certificate. And after you create all this, then you can verify the cert. So it will execute getting an output. And next step, so you can create really simple Python script I already uploaded to the D2. Let me see if you are able to see it. Called IoT security. So you can just copy or create a new one. So it will be look like this IoT security. Okay, so including with the cert and connection with the circuit. Basically you can just setting up. You just show me, okay, it works. So also I put the code snaps right here. If you basically set up all the cert, just make a screenshot and then make sure they're all setting get the files, and you're able to get it, and then you can check, because when you install the fail to ban, it will monitor all the logging. So they will block some malicious IP address. Also, you can allow the system logs to review the logs from suspicious activity. Let's say you can just do the journals CTL and then with the SSD. So this one would be all the log. So you're able to see, okay. And then you can final the testing and then demonstration. Maybe you can later connect through the HTTPS or see the logs. as the first lab, you just need to, I already post the assignment as a first lab. It's pretty straightforward. You're not really required to able to set up the setting for the using SSL teaser, but at least like you show me, okay, you try to you're already able to download the OS, connect to it, and then able to connect to it and set up the like certificates. Okay. And maybe you're not able to monitor the SS or get the log, but it's okay. But so far you can like stop by at the moment is like how can you connect to it and then add the SSL. Okay. So with the key, that's what you need to do. And then with the Python code. Okay. These are basic requirements for the lab part and then for your assignment. So just let you to try. Okay. And so far this will be your first assignment. Like kind of just a warm up and then just like set up the environment for a future work. And I will move on and just like we're not going to cover all the lecture, just the introduction, and then later we'll come back. So just need to know when we talk about the IoT architecture and some communication protocol, then we need to know, okay, understand some architecture components and then how the communication protocols inheritance security issue, and then we can gain some like hands-on experience, let's say. By other lecture, because I try to get some exercise lab, you don't have to do it, but if you're interested, and I will try to include some extra information you can use later. Okay. Give you some best practice. Okay. For the structure, we will look at all the components, maybe some devices, gateway, cloud, data management, and also pretty common IoT protocol. So we're going to discuss. And also we have the device to cloud communication security. So what's the security risk? But in our topic, we'll talk about smart things security. For in the beginning, we need to know the infrastructure, how it works, architecture. Then based on the architecture, then we need to know, okay, so what the possible security risk, and then what kind of best practice can secure the communication. Recap of it, we go through all the definition, IoT, so we refer a network of physical devices embedded with the sensor, software, other technologies, allow them to collect and exchange data over the internet. And mainly for the IoT, the key characteristic, including the connectivity will be those devices that connect to the network and share, receive data, the interoperable. So the T will be the IoT system. They will involve the devices from different manufacturer and platform. So, but they need to work together. So here's the tricky thing, because those devices, they are from different manufacturer and they have to working together. So that's why it's the how we scale it. So that's why we always know for the OS like Apple, why so secure Windows or why the Android, they always have some lots of backdoor risk because they are combining, putting different manufacturers stuff together and platform. So that's why you never know, or they want to make it easier to communicate that it causes the issue. And then how can they try to, for the IoT devices, they always collect real-time data. That means how can they process the analysis, and when they transmitting, what's the risk in behind, and then automation and then control. So they can how to automate the task and provide some remote control to the user. For example, the smart home, some industrial monitoring. So all this, how it works. For the like devices, so it will be the edge of the IoT system. So which like we can collect the data from the environment, so including the temperature sensors, motion detections we are using. For your Raspberry Pi later, maybe you can use on the sensor. So part of it is like later I would like to let's set up the meeting maybe individually, so you can like tell me what you'd like to do, then I can keep guiding you. So it's more like it's a we try to work on some project. So we are not only just like go through the lectures definition, but I wish like if you can work on something and build a project using the Raspberry Pi. So for some sensor, maybe you can use for house, because I know in our third floor there's a called the apartment, right? So also if you want to try, I can try to get some permission, so you can like test it or like set the Raspberry Pi for doing some like sense the temperature actually, if you were doing at home, it's fine. So to doing, I think it's easier. And then we don't have to get certain permission or like limitation. And because those limitations maybe have low power and constraint in the processing capability, then we also need to fix those problems. And in the IoT system architecture, so we do have the gateways. So gateway as like the intermediates between the IoT devices and also the cloud or like API server or others on the network. So then we translate the communication protocol, like the ZB to the HTTP, or they maybe handle some local processing, let's say the edge computer, to reduce the latency and bandwidth requirements. So we need to know maybe for IoT stuff, so are we sending all the data in real time, like bit by bit, or are you going to store it and then send it to the cloud? So either way is okay. When I talk about the cloud, right here will be the service like aggregate and like store, process data from the IoT devices. So it can support the data analysis and then some like maybe some AI machine learning model, so we can use and provide a user interface to read it. Okay. And so for the architecture, we do have the data management. So we need to deal with the data storage, pre-processing, and do the analysis, including all this. And we need to just make sure data they're properly like structured, okay, managed. We can say as NoSQL, because for the handle real-time large amount of data, similar structure, then we better than using NoSQL and easier, okay, for analysis and insights way. And including, okay, so we already looked the basic overview, then we talk about the devices, all those like devices, including we talk about the sensor, like the activating, the controlling actions for the input, like turning on the lights and outputting the valves. And then we also have some like edge devices. So actually maybe some like local device or microcontroller, they can like process store data before sending it to the cloud. So we call the edge devices. So that one, most of the idea, you're just thinking this one would be the Raspberry Pi. Okay, sensor goes to the Raspberry Pi, save it. So you and then embedded system, including maybe some resource constraint, maybe CPU, memory, powers, all this, maybe some lightweight protocol we need to use. So all this actually coming together will be like we putting together to the Raspberry Pi. So just pretty straightforward to do it. Then we need to think about what the possible challenge, including the power limitations, maybe the battery power devices, and also the limited processing power of complex operation, or when they have a device failure and then downtime, how can we do? Later for the task you need to do is they try to do the checking the heartbeat. So we call heartbeat, that means that make sure that your IoT devices, that means that Raspberry Pi is alive. Okay, how long is the alive time or downtime when you go back to connect to the internet? Okay, so also we need to work with and then reliable devices for the industrial IoT. This one we need to know in theory, but most of them we handle with a small one. Okay. For the gateway, we talk about it, and then it's mainly is provide network connectivities, so between devices. So maybe including the Wi-Fi. Right now, all the Raspberry Pi including Wi-Fi, Ethernet, also maybe cellular we can connect to it. And it performs a protocol translation. So it enabling the devices with the different communication protocol. HTTP. The one we're going to use HTTP with the TLS. So in the lab, so you need to able to do that. And then the edge processing, so that's what Raspberry Pi we're doing. So many RD gateways capable of running language application. And also some pre-processing data to reduce the latency and minimize the data sent to the cloud. That's what we need to do. So after we read the every second, actually within 1 second, depends how you write your Python script and how often you read the data. Maybe you can read it even every second. We have 10 copies of data or just one, depends on how frequently you get the data. Okay. And also like maybe we have some IoT devices like the smart thermostat that will send the data to a gateway, and then we filters and forward the relevant information to the cloud service. That's what we need to do and make sure all the devices changing. Or maybe you try to trigger, okay, if there's a change, we update, send to the server, but it never changed, then we can just stay as the same way. then it can save the transmission. And we need to know for the gateway, what's the security challenge. For the security challenge, we will including gateway, they are like vulnerable point in the IoT structures. So we need to be careful. They will be always the target by the attacker, so they will get access. Because sometimes we talk about the gateway, they maybe save all the information, data. So once they get access, then they will control everything. Okay. And then they are mitigating the risk, like so the like proper encryption and device authentication or some software update. That's what we need to do on the gateway. The next one is the cloud. So we talk about the cloud. So it will include the data, the aggregation. So they will collect and then store the massive amount of data from the IoT devices for the long-term storage. So here's the key thing: is a long-term, because for the huge amount, you will see the maybe like every day and then weekly, monthly, yearly, so multiple years. So you see how much amount of the data we're going to generate. So you see even coming. And based on the data we save, we will analytics, and then you say for the AI. So maybe they will do the analysis. So based on they will extract some insights or some detect some anomalies or some triggers an automated response based on they can like have some like predictive maintenance, energy optimization, anything they are possible. So it's nowadays it's a trend use the AI. Use it to monitor, control the IoT device remotely. So later with the next one, I need to let you. So just letting you know. So you know the GPIO or the pins. So how can you get it? It's on. So I know there's some framework you can use, and also you can build your own to control it. Okay, most are easy. Like there's a LED. Then how can you turn on LED and turn off? Okay, how can you say remotely? And later, how can you send a message? Then how can you turn on the LED like this? So we can provide and offer some elastic compute power and storage. We can try to do okay. And more part of some popular IoT clouds will be the AWS IoT. So it can provide tools like device like management and latex security, or Azure and Google. So they are three big tech companies. So now, so they include the IoT hubs, the devices like provisioning and cloud-based like data processing. And for Google Cloud, they also will have a feature like connect the devices to the cloud service with the data processing. All they do have very similar features and competing each other. So you may choose your own, but for the our lab and for connection, and later you can send it back to your own laptop, or you can create a VM, or you can use the free type AWS to host the API server. Later we will also try to set up the API server to save the data, and even you can use the Google spreadsheet. So like using Google Save to the Google Drive spreadsheet is okay. So either way is okay, flexible. But when you see like for the cloud and everything, so we need to concern it is the security in the cloud. So how the data are being encrypted, and then how to set the access control, or are we going to add some multi-factor authentications or some secure APIs? So they are like crucial. So this we need to pay attention with. And for the west part, because I suppose will be for the lab, then I will break down all this. For the next one will be later. So we'll be go through the lectures. Okay. So far we start by right here, and then I will create another video to going talk about the lectures. Thank you.